Alright, for part 2, we're going to work on graphing parametrics, something we've already covered, but let's go ahead and review. So we'll take a look at an example. Let's say one of our parametric equations for x is t minus 1, and the second one is y equals negative t plus 2. And we want to sketch this. Now remember, what a parametric is going to do is, given the independent variable of t, it's going to give us the x and y coordinates of a point. And we probably want to get quite a few points, so let's go from negative 3 to positive 3. And what we're going to do is we're just going to plug these each in. So to get x, to get my x coordinate, I plug negative 3 in. And that's going to give us negative 4. But if I plug into the bottom one, two negatives make a positive, and that gives us a negative 1. Sorry, positive. That becomes 3 plus 2, which is 5. My bad. So we get negative 4, 5. Plug in negative 2, we get negative 3. This becomes 2 plus 2, which is 4. So we get negative 3, 4. Plug in negative 1, we're going to get negative 2. Plug in negative 1 here, becomes 1 plus 2, which is 3. Plug in 0, that's easy, negative 1, 2. Plug in 1, we get 0, 1. Plug in 2, 2 minus 1 is 1. Negative 2 plus 2 is 0. And plug in 3, we're going to get 2, negative 1. And you can verify that if you need to. And all we're going to do now is graph these. So when you're graphing these, give yourself some space here. Negative 4, 5, 1, 2, 3, 4, 5. Negative 4, sorry. 5, 1, 2, 3, 4, 5. That's where we're starting. Negative 3, 4. And we're heading in this direction. They're like vectors. They're heading in a specific direction. Negative 2, up 3. Negative 1, 2. 0, 1. 1, 0. And 2, negative 1. And if you notice, what do we get? A line. And we can verify that. We can plug it in. Because remember, if x equals t plus 1, this is saying t equals x plus 1. And then just plug it in. Y equals negative x plus 1 plus 2. Or negative x, that becomes minus 1 plus 1, so plus 1. And there's the equation of our line. But remember, we're limiting our domain. Now, we made up these numbers. Sometimes they give them to us, but we do have a domain restriction. We're going to go from negative 3 to 3. We change our domain. So this is like, basically, it's a line segment, a directed line segment. All right, so let's take a look at another example. Okay? Let's say we have x equals t squared and y equals t over 2. Let's pick some points. Now, I'm not going to pick so many points this time. T, x, and y. I'm starting at negative 2 this time and going all the way to 2. If I plug it into the square into here, we get 4, and this becomes negative 1. So there's my first point. Plug in 1, negative 1, we get 1, negative a half. Plug in 0, 0, 0. Easy, don't miss that one. Plug in 1, we get 1 and 1 half. Plug in 2, we get 4 and 2. And, whoop, that should be 4 and a 1 there. That's awful. 4 and 1. Alright, so let's sketch it. Let's see what this looks like. Plug in a few points. This would be kind of a cool one you're going to see. 4, 1, 2, 3, 4. Negative 1, this is where I'm starting. Can't spell start today. So that's where we start. The next one, 1, negative a half. 0, 0. 1, 1 half. Oh, I'm coming back. Not even a function. 4, up 1. What does this look like? Waiting, 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 because that's where I'm ending. That's right. This is a parabola. That's a parabola. It's a sideways parabola. And we can verify that by looking up here. But this time, use the bottom. If I use the bottom, we're saying t equals 2y. And now if I plug it into the top this time, we get 2y squared. So x equals 4y squared. And we now know that that's a sideways parabola. We have a range restriction this time. We have a range restriction because in terms of y. And what's our range restriction? We're going from -1 to 1. You can use your domain restriction from 0 to 4, but range restriction just looks so much cooler. All right, let's take a look at one last example here, okay? One last example, and that's with absolute value. X equals t, y equals the absolute value of t plus 2. Okay, so if we try this one, make your table, t, x, and y. Let's go from -3 to 3. Plugging these in, that's easy. The x's, easy, don't miss those. Plug in the y's, -3 plus 2, that becomes a 1 because absolute value. 0, -1 plus that, that's a 1. 0 becomes a 2, 1 becomes a 3, 4, and 5. Easy breezy. Look at the points, -3, 1. -2, 0, -1, 1, 0, 2, 1, 3, 2, 4, 3, 5. And I'm going to graph these. -3, up 1, this is where I start. -2, 0. Draw your arrows, -1, 1. Oh, look, we're going back up. It's not a parabola this time. 0, 2, it's more linear. 1, 3. 2, 4. 3, 5. And there's where we end. If you do this right, one gigantic check mark. Good job. So this is, of course, our absolute value, which is obvious to see here, right? So they're saying x equals t. This is our graph of our absolute value function. And we said x equals t, so if I just plug it in, I can just go with the absolute value of, instead of t, x plus 2. And that is definitely our equation of that. So try these again if you need to. We'll talk more about these tomorrow. See you then. Bye.